Hello, everyone. In this video, we're working through an introduction to statistical methods and data analysis by Ott and Longnecker, Chapter 13, Part 2, Model Building and Diagnostics, Residual Analysis. So we're going to look at some prototype residual plots just so that we can see, like, with fake data, what would a residual plot look like? What would the scatter plots look like? So first, I'm going to create some normal random variables using the rnorm function. And I'm going to create 100 normal random variables with a mean of 10 and a standard deviation of 6. And then I'm going to create 100 random errors with mean 0 and standard deviation equal to 3. I'm going to set yi equal to xi plus epsilon I. And I'm going to create a fit of the yi on the xi. So these ei's are unobserved, but in real life, these ei's are unobserved. But in this case, we're simulating this data so that we can see the relationship. We build our fit using the ln function, and then we get a summary of our model. So here I should get a slope of 1. And when I look at the regression line, right, we see that we get a slope of 1.04. So it looks pretty good at estimating the slope between x and y. We get an adjusted R-squared value of 0.822. And we get a scatter plot, and we can see that the points lie on a line and they're scattered. And our residual plot, it looks pretty random. So this is in a case where things are looking pretty good. Next, if we create a model where we simulate some random variables for x, right? And we do the same thing for the ei's. But instead of yi being a function of just xi and the random error, the truth of the matter is that we set yi equal to xi plus xi squared plus epsilon I. But this is what you usually don't get to observe, right? But we're going to just fit the model on yi and xi. And when you do that, these estimates, right, the slope for the xi is no longer estimated to be close to 1. Now it's being estimated, the slope is being estimated to be 19.19. And when we look at the scatter plot, we can see that we have this kind of parabola shape going. And when we look at our residual plot, that doesn't look random at all, right? So when we saw that parabola on the residual plot, that tells us that we probably also need to model using the linear model function. We need to have an xi squared included. So we're going to transform x. So when we do this, we could fit a new model. We're going to call it fit.b. And when we fit that model, all of a sudden, things look a lot better, right? So we're going to have this indicator function with the xi squareds that's telling us, hey, add an xi squared into our model. And when we look at these estimates, all of a sudden, those are giving us slope estimates close to 1 for both the xi and the xi squared. And the reality is the underlying model that we had was yi equals xi plus xi squared plus ei, right? So now when we look at our residual plot, now that we have the correct function, now our residual plot looks random again. So this is why we're using our residual plots to get this information so that we can actually see if we have a good fit to our data. All right. Let's take another example where the xi's are no longer going to be normally distributed. Now they are going to be log normal distributed, right? and our EIs are still normal distribution. So when we fit our YIs, right, to our XIs, what ends up happening is we have this curvature, right? And when we look at our residual plot, we have a lot of this curvature in our residual plot. So we know right away that we need to do some sort of transformation, right? And so when we transform the data, right, we can do this fit.b where we have yi follows xi plus the indicator of log xi. When we do that, all of a sudden, our residual plot looks much, much better. Still not perfect, right? But it looks a lot better than before. And, you know, we might have to do some fixing, but it looks a lot better than before. We might just have this like influential point out here that might be pulling our line that we might be concerned about. But other than that, it looks much, much, much better than before. So essentially here where we said, okay, we might have some fanning, we might also think about transforming our Y. Sometimes you can try these first transformations to see what looks the best. A square root Y transformation, 1 over Y, or log Y are common transformations that you could possibly use that would help your model fit. So overall, I hope that these examples showed you with some fake simulated data, things that you could try, or what your residual plots might look like when your assumptions are violated.